Ever struggled with keeping your fastmcp server configurations consistent across different environments? You'll see how a single fastmcp.json file replaces complex command line arguments by declaring your server's source location, environment requirements, and runtime settings in one portable configuration. We'll break down how this structured approach ensures your server runs the same way everywhere, from local development to production deployments.
Schema https://gofastung.com/public/schemas/fastmcp json/v1 json. Source: where, location of your server code. Type: file system, optional defaults to file system. Path: server pi. Entry point: MCP. Environment: what? Environment setup and dependencies. Type: UV, optional defaults to UV. Python, >310. Dependencies: pandas, numpy. Deployment: how? Runtime configuration. Transport: SDDO. Log level: info.
This configuration demonstrates the declarative project pattern, where infrastructure and runtime behavior are defined through structured configuration rather than imperative code or command line arguments. The approach codifies the three fundamental concerns of any deployable service: source location, environment requirements, and execution parameters into a single, version-controlled artifact. What distinguishes this pattern is its separation of what should run from how it should run, enabling consistent behavior across development, staging, and production without modifying application code. The pattern works by externalizing operational concerns into a schema-backed configuration file that serves as the single source of truth. FastMCP's design treats the config as a build manifest. The source section locates the executable code, the environment section defines the reproducible build context, dependencies, Python version, and the deployment section specifies runtime behavior, transport, logging, environment variables. This separation allows tools and platforms to reason about the project's requirements before execution, enabling pre-flight validation, environment caching, and cross-platform portability without embedding those details in the application logic. This approach solves the problem of environment drift and works on my machine inconsistencies by making the deployment contract explicit and machine-readable. It's particularly valuable for teams collaborating across different setups, CI/CD pipelines that need deterministic builds, or scenarios where the same code must run in diverse contexts: local dev, cloud, edge devices. The trade-off is initial setup complexity, but the payoff comes in reduced operational friction. No more documenting CLI flags, no more manual dependency installation, and no more environment-related bugs slipping into production. For projects that outgrow simple scripts, this pattern becomes a force multiplier for maintainability. Let's break it down line by line. This opens a JSON configuration object. JSON's curly brace syntax defines the root structure for FastMCP's project configuration, where all deployment parameters and environment settings will be specified.
Schema https://gofastung.com/public/schemas/fastmcp json/v1 json.
This JSON schema reference enables IDE validation and auto-completion. It points to the official FastMCP configuration schema, ensuring your config file stays correct and gets real-time feedback about valid properties and values.
Source:
the source key defines where FastMCP finds your server implementation. It specifies the entry point for your AI callable tools, ensuring the framework knows which Python file and function to execute when the server starts. This follows the standard configuration pattern for locating and initializing the application code.
Where? Location of your server code. Type, file system. Optional defaults to file system.
This specifies the source type as file system, telling fastmcp to load the server code from local files. It's the default option, so you only need to declare it if you want to be explicit or override a different global setting.
Path, server pi.
Specifies the entry point file for your fastmcp server. This is the Python module containing your @mcp tool decorated functions and the MCP instance that fastmcp will execute. Without this, the system wouldn't know where to find your server logic.
Entry point, MCP.
This specifies the function name that fastmcp calls to start your server. Without it, the framework wouldn't know which function initializes your application, so this entry point is mandatory for execution. This closing brace terminates the environment section, completing the configuration block. JSON requires explicit section boundaries, and this syntax ensures proper parsing while maintaining clean separation between configuration areas.
Environment.
The environment block defines the runtime requirements and dependencies for your fastmcp tool. It ensures the execution environment matches what your code needs, preventing version conflicts or missing packages. This is where you specify Python version constraints and external libraries.
What? Environment setup and dependencies. Type, UV. Optional defaults to UV.
Specifies the Python package manager for dependency resolution. Using UV here enables faster dependency installation and virtual environment creation compared to pip, optimizing the development workflow. This is the default and recommended choice for fastmcp projects.
Python, greater or equal 3:10.
This specifies Python version compatibility, requiring version 3.1 or higher. It prevents deployment on unsupported runtimes and ensures access to modern language features like pattern matching and type system improvements.
Dependencies, pandas, numpy.
This declares the Python package dependencies required for execution. fastmcp automatically installs these via pip before running your tool, ensuring the environment matches production. Standard dependency management, pattern for reproducible deployments. This closing curly brace terminates the environment section, completing the JSON object structure. It ensures proper syntax validation and prevents parsing errors when fastmcp loads the configuration.
Deployment.
The deployment section defines runtime behavior and execution parameters. It controls how fastmcp runs your tool, including transport mechanisms and logging verbosity, ensuring consistent execution across environments. This is where you configure the operational characteristics separate from the code logic.
How? Runtime configuration. Transport, SDDO.
Specifies SDDO as the transport mechanism, using standard input-output for communication between the fastmcp server and the AI model. This is the simplest transport method, ideal for local development and debugging, where direct process communication is preferred over network protocols.
Log level, info.
Controls the verbosity of runtime logs. Info level shows operational messages like server startup and tool execution, while filtering out debug noise. Critical for production monitoring without overwhelming logs. This closing brace terminates the JSON configuration object, finalizing the fastmcp deployment specification. It ensures the entire configuration is properly structured for the fastmcp runtime to parse and execute. Without it, the file would be malformed JSON and fail validation. Closing brace terminates the JSON configuration object. This ensures valid JSON syntax, preventing parsing errors when fastmcp loads the file. Always verify matching braces in configuration files. Fastmcp configuration pattern. The JSON schema approach replaces CLI complexity with declarative structure, separating where source, what environment, and how deployment into clean, version-controlled layers. Omitting the schema field disables IDE validation and autocomplete, making configuration errors harder to catch. A well-structured, fast MCP. JSON becomes your server's single source of truth across development, testing, and production.
The configuration file that disappears into the runtime reappears in every error message